Alright, so I'm going to show you how to use roots of quadratics to answer this question. So the graph of y equals x squared plus 4x is shown. So we know this is this graph. Okay? For what values of x is y equal to 0? So this is really asking what value of x, so coordinates are x comma y, right? Is y equal to 0. So I'm looking for the coordinates where y is 0. I can solve this one of two ways. I can just look at the graph and look for coordinates where y is 0. So for example, this coordinate here would be 1, 1. This coordinate here, which is one on the graph, is negative 2, 1, 2, 3, negative 3. And then this coordinate here, for example, this is 0, 0, which is what we were looking for, because that's a coordinate where y equals 0. This coordinate here is 0, comma, 1, 2, 3, 4, negative 4. Oops, no. It's left negative 4, up or down 0. So this is another coordinate where x equals 0, or sorry, y equals 0. So the values where y is 0 are negative 4 and 0. The other way you could have solved this is by taking the equation and substituting in 0 for y, and then you could have solved this, okay? By factoring out an x, see that both of these terms have an x. This is just the zero product property where a times b equals 0, so either a equals 0 or b equals 0. So x equals 0 is already an answer. Here I would subtract 4, and I'd find that my other answer is negative 4. So either looking at the graph and finding the coordinates where y equals 0, or you can solve it algebraically if you wanted to. Okay. Let's do one more. Question 13. Question 13, which equations correspond to the graph below? And so equations, so I see that there's going to be more than one answer. And what I need to do is I need to look at this, and I see here, for example, that the x-intercepts are negative 5, 0 and negative 3, 0. So I need to find out which of these equations has these two as roots. Remember, roots are the same things as x-intercepts. And all of these are also solutions. And solutions happen when y equals 0. So what I could do is I could try b and say, well, if y equaled x squared plus 3, if it equaled x plus 3 times x plus 5, and y was 0, would this have these roots? So if it equals 0, then either a or b equals 0. So either x plus 3 equals 0 or x plus 5 equals 0. Subtract 3 on both sides, x equals a negative 3. Subtract 5 on both sides, x equals a negative 5. And these are actually the roots, so b is my answer, because it would have roots of x equals negative 3 and x equals a negative 5. And so what I really need to do now is I need to multiply these things together to see which of these it is. So I could multiply using the box method, x plus 3, x plus 5. So you get x squared plus 5x plus 3x plus 15. So x squared plus 8x plus 15. So these two equations are actually the same exact equation, and they are the answer to this problem.